Welcome back to Hardburn Double O. On the workbench today we've got a DCC next. I did actually buy two from Nico over in Holland. I plan to use one as a signal decoder and the other one I'll be using as an accessory decoder. So I thought I'd do a little video to show you how I go about building up the board. It does come with a comprehensive set of instructions. The board is very well designed and easy to solder, and also you get a full list of instructions as well. The first thing on the instructions there is to place all resistors R1 to R8. R1, R2 and R4 are all 1K. So rather than confuse it back, I've got them all set up here. I've got them all set up here in the order they're going to go in. So I'll put all the 1Ks in first, and that's going to be R1, R2 and R4. And then I'll do the 10Ks, and then I'll do the 2Ks. If you're unsure about the coding, it is marked down here, the colour banding. You could also use a multimeter, or in my case here I use the multifunctional tester to make sure I've got the right component. So I'll get the soldering iron hit up and we'll start putting the components in. I'm not going to show you soldering every single one. I'll show you where they go as the build goes on and try and do a time lapse. First up is 1K resistors. If need be, you can give the legs a little clean. The same with the board, you can give it a little clean. I tend to use the wife's toothbrush for cleaning things. It doesn't do too bad job. I also like to use a little spacer to keep the components off the board. Just use the little bending jig, bend it over. And the first one is R1, this one down here. Brown, black, black, brown, brown, or as I say, you can use the little multi-tester TC1, costs about £10 from eBay, a great little tool. So on the board it's marked R1 as well. We'll slide it in there. I use my cross-action tweezers just to hold things in place while I'm soldering. Just pre-tin the solder. Get a little dab, 2-3 seconds, and then lift the solder iron up the leg. And these are clean. I use a scrubbing pad, metal pad, to clean my solder iron. So that's number one in place. You can, if you want, cut the legs as you go, which I like doing. Of course, there's no reason why you can't put more than one component on at a time. It's just for a bit of demonstration purposes. I'll be doing one at a time. So that is R1 now in place. Next one we've got is R2. So that is R2 now in place. As I'm doing all the 1K resistors, I need to remember it's R2, R1, R2 and R4, not R3. Ask me how I know this. So that is R4 now in. I should say with the resistors there's no need for polarity, they can go either way around. Now we're going to R3, R6 and R7, 10K ohms. Brown, black, black, red, brown. So that is R3, the first 10K resistor in. You can, if you wish, as you go along, just tick off each one and it keeps you right. Take two. That's R6 in, so now the one above it is R7 and it's a 10K as well. I've left a lot of spacer in there just to save a bit of time. So that is R7 in now. Now going to R5 and R8, which is 2K. Red, black, black, brown, brown. So that is R5. Next one we need is R8, which is the last 2K ohm resistor. So that is the last resistor now in place, R8. Now we can move on to the next step. And the next step in the instructions is to place the diode D1 and note the orientation. It is quite important we get the band in the right place. On the diode there's a white band on this side here. Looking at the circuit board, the white band goes to the left hand side. As you can see, it's clearly marked on the circuit board. So that's the diode D1 with the correct orientation, white band to the left hand side. Next up is the bridge rectifier. I'll try and zoom in so we can see the orientation there. You've got a plus, a minus and the AC side, this side here. And on the chip it is also marked the same. It's quite important you get the bridge rectifier around the correct way. That's the bridge rectifier now in. The plus side is on the right hand side and the negative side is on this side here, both facing up the way. Next up we have got the voltage regulator. This is the voltage regulator at L7805 and you can just see the marks here. If you get a pair of pliers, hold it on the marks, then you can bend the legs over backwards. It has got to be sitting in so the plate sits on the heat resistor. So I'll test fit it first, make sure the hole for the bolt is secure. Make sure it's sitting flat. So that's us. The hole for the bolt matches up, we can solder it. So that is the 5 volt voltage regulator now in, and I secured it using the supplied bolt and nut, or screw and nut. Next up we've got the capacitors to go in. You miss out C1 and C3 and you do the other ones, C2 all the way through to C8. With the disc type capacitors you don't need to worry about the orientation, they can go anywhere around. Now I tend to work from left to right. I've got them up here. I've got my 100 microfarads, it's marked with the disc 104. I've got my 22 picofarads, it's marked 22 on the disc, and up here, it's quite hard to see this one, it's 221, or it's a 220 picofarad capacitor. That's when the machine comes in really handy to test if it's the right capacitor or not. There we are, 210 picofarads, which is perfect. So I'll put one up to the side there and I'll do that one last. We'll do all the 100s and then we'll do the 22s and then we'll do the 220. So the first one in is C2 100 microfarads, and it goes in this point here. So that is C2 in 100 nanofarads. Next one we go is C4 100 nanofarads as well, which is this part of the board here. Quite hard to hold these in sometimes. I use a bit of blue tack, you just need to watch, don't get the blue tack against the legs because it will melt and cause a bad connection. So that is C4 in there. Next one up we have C5, which is over this one here. C5 100 nanofarads. So that's C5 now installed. The next one we have, which is 10 microfarad, is C8. That is C8 now in. Now we're going to the 22 picofarad ones, C6 and C7. So that is C6 now in place. Disc is marked 22 for your 22 picofarad. That is C7, 22 picofarads. Next up we have C9, which is the 220 picofarads. So that is C9, the 220 picofarad, and it's marked on the disc 221. It is very hard to see sometimes, so do take care. Next up we have the IC pads or sockets. It does say in the instructions to do these third, but I like to get the small capacitors in before I do the IC feet. And on the IC feet as well, it's got a little bite mark. So that indicates pin 1. So this small one here, I'll sit in with the bite mark to the left hand side of the PC board. So that's the first IC socket in with the bite mark facing the left hand side. Now we'll do the same with the big one, and the same again, the bite mark goes to the left hand side. So that's a big long IC socket now in place. Now we're going to go down to the LEDs. It should be noted that the LEDs has got a long leg and a short leg. That is quite important, you get it round the correct way. The long leg is positive and the positive goes to the top for every LED on the board. So it's long leg to the top. So that's the green LED in, that's the red one in, so that's the blue, and that's the yellow LED in now. Next up we've got the jumper settings for the power. You need to cut 3 2-point connectors. The long part goes to the top of the board, the short part goes to the bottom of the board. And the trick is, when you're trying to install them, is to use the jumper setting to hold it. So that's the jumper setting in now. At the moment I've stuck it on internal just for testing purposes. Next up we have the serial port here. You cut 6 DuPont connectors to the correct size, and the same again, the short end goes in that side. Next up we've got a choice. We can either use these little block connectors in here, which is fine for doing signals and lights and things like that, or we can put in 3-pin DuPont connectors in here. For me, I'm going to be using 5 servos with this board, so I'll put in 5 DuPont connectors, and then the last ones I'll use the block connectors for frog polarity and signals. So I actually put 6 DuPont connectors. I built in a bit of redundancy as well. I've got quite a few spare ports on this board. Now I'm going to put in the blocks. With the block connectors, there's a large blue and a small blue. Sometimes it's not blue, depends what kit Nico's got in stock. It may be green, but the small one goes in the +5 ground volts. So that's the block connectors set up here. You put them along what you call the signal line, the white band of this one here. Now we're going to put in the 3 power DCC block connectors. Next up is the smaller of the 2 CAN capacitors. The same again, it is important you put the polarity around the correct way. You've got a long leg for positive, a short leg for negative, and on the capacitor as well it's got a band marking negative. On the board it is marked positive, so the positive leg or the long leg goes to your right hand side. Last up is C1. And the same again, it's quite important you get the orientation around the correct way. This is the positive leg, and this is the minus leg. One lead positive, it's got a black bend for the negative. Also on the board it lies flat down. So prepare the tweezers. Pliers. You may, if you wish as well, to give it a little added stickiness, use some what you call black tack. It's a rather good electrical insulator that keeps the component off the PC board. The C1 now installed. Now the instructions say to put in the chips next. What I prefer doing is checking the voltage is correct for the chips. If they follow the voltage in the positive there, it comes down here across to pin 7. The ground is on pin 22, the opposite side. So you put a multimeter set on DC voltage between pin 7 and pin 22, you should get 5 volts. Up on the optocoupler as well, follow the voltage in down here. Pin 8 should be the positive and pin 5 is the ground. So same again, if I put a multimeter between pin 8 and pin 5, we should get 5 volts. So I've got the power connected up. I've gave the back of the board an inspection using my magnifying glass as well. We're ready to power up. I have set the internal power to the jumper setting to internal power, the bottom one here. I've attached 12 volts in here. As it's got a bridge rectifier, you don't need to worry about which way the wires go. The bridge rectifier will sort out for you. So I'll power it up, we'll get a voltmeter over and test pin 7 and pin 22 and pin 5 and pin 8. So that's it powered up, you can see the power lights came on. I'll switch the voltage meter on to DC and I'll check between pin 5 and pin 7. And there we have it, 5 volts between pin 5 and pin 8. 5 volts as well. So this is good to put the chip in. It is advisable to earth yourself before you touch these chips, especially the ET Mega. Some static electricity in your body could actually damage the chips. So the first chip in is the optocoupler. The same again, you've got to note the orientation. The bite mark on the chip, or the dot, is pin number 1. It goes to this side here. The last chip in is the AT Mega. Sometimes can be a bit awkward to try and get it in. You've really got to make sure that these legs are straight. Same again, pin 1, this side here goes to the left hand side. So that's 2 chips in the place. When I switch on now, the power light will be on steady and the status light should be flashing, which means it's ready to get programmed via the serial port. So there we have it, the power light's on, the status light is flashing, which means the chip is now ready to receive either the Bardec program or the RSIG program, depends how you want to use the module. On the whole, a very easy kit to build. If you want more details on how to program the chip, I'll leave a link down below for Rudy's Model Railway. He's done some fantastic videos on setting up the full unit. Thanks for watching, folks. Goodbye.